You want to FOIL that first. And as a result of foiling, the I should go away. Now there is a shortcut for this because it is an A plus BI and an A minus BI situation. And you really do want to, at some point, commit to that. You don't want to FOIL each time because you learn that this becomes A squared minus B squared I squared. And I squared is really -1. So this really becomes A squared plus B squared. Okay. So when you FOIL this, or when I FOIL this, doesn't really matter. The A is the 2x and the B is the 3 without the I. So it becomes 4x squared plus 9. Okay, now if we FOIL it, we're going to see the same thing. We're going to see that you get 4x squared minus 6xi plus 6xi minus 9i squared. The two middle terms cancel.
And the other one turns into +9.
Yeah. And you might think, well, that's not a big deal. Well, it is. I mean, you need to save time on this thing as much as you can because you're gonna now have to FOIL this, which there is no shortcut, and then double everything. So the more you can kind of do, the better. Right. So we FOILed it. So 12x cubed plus 20x squared plus 27x plus 45. And like I said, you're doubling. 24x cubed plus 40x squared plus 54x plus 90. If you can do all that, the rest of this is just stuff you've already done. The degree, leading coefficient, and all that. So, this is kind of like, well, if you can get to this, you got it. 3, 24. You're supposed to know those graphs. So since the degree is odd and it's a positive leading coefficient, we know that it starts low and ends high. So the right end behavior here, as x goes to infinity, f of x, the reason it's f of x is because it was given as f of x, goes to infinity, positive infinity. Left end behavior as x goes to negative infinity, f of x goes to negative infinity like that. So I want to do P1 for you, but I guess, is there any questions or thoughts on this? Overall, like, from start to finish here, the fact that you do want to deal with the I stuff first.
Got it. And then yeah, then you add in the.
Exactly.
Wait, so where do you get the 3x plus 5 again?
Oh, I guess it was 4x plus 5. Oops. That does impact everything. I messed that up. I mean, I would just change the example in the classroom, but yeah, I mean, it changes all this. Let me actually rewrite it.
All right, so then you just
Sorry about
multiply
that.
it. Oh, got it. So once you find the FOIL of the two binomials, you just plug it in there and then solve it by multiplying by the
Yeah.
two, and then got it.
It doesn't change. I mean, it's very negligent of me to do that, but it doesn't change like any of this other stuff. It just changes the numbers. Um,
Got it.
so let's look at P2 now because P2's got more going on in it. Like I said, like your instructor, like this is the example. This should be the example, not the practice. So it's still, believe it or not, is in this like A plus BI form, even though it doesn't look like it. So um, if you were to distribute the negative here, you'd have x minus 2 minus 7i, x minus 2 plus 7i. You see the negative going into both of these, that this is what it becomes.
Yeah.
Now, believe it or not, it's still in this A plus BI form. A minus BI. It's A minus BI, A
So do
plus
you take,
BI.
so if I'm wrong, you take x minus 2 as A and then
Yes,
7i
exactly.
as B.
Exactly. Exactly. And your teacher wants you to do this. Like this is not Matthew showing you like a, weird advanced thing here. Your B is 7. So it becomes A squared plus B squared when you're all done. Now, if you want, you could FOIL or not, well, not FOIL anymore, but you can multiply everything out. It's really messy. It's better if you can do this. It really is. Like I would just commit to this right now and say, all right, I'm going to commit to it. And yeah, it's going to be harder the first few examples, but it's going to save you a ton of time on the exam. All right. So now you do have to expand the x minus 2 squared. So if the more that you can draw on these formulas, the better. A squared minus 2ab plus b squared. The more you can draw on those, the more time you're going to save. Okay, so that is these first two. These first two, after all of this work, you can take a look at that, becomes this. You still have to bring down this thing right here. So the idea is that all the i's disappear.
Got it.
All right. Now, I would like you, get involved here. I'd like you to multiply all this. And just be careful that you can choose the direction, right? Like I would actually tell you it's better to do it where you multiply the two binomials. I would prefer you do it where it's these two times everything in here. And furthermore, I might even suggest rearranging it like this so that you get everything kind of ordered correctly. But that's up to you. Like little things here and there. Um, so go ahead and give that a try, please.
All right, I got minus or negative 2x to the fourth plus 8x cubed minus 103x squared minus 12x plus 159.
That sounds correct here. I used the calculator to make sure I didn't mess this up. I believe that's what you said here. All right, so the next thing here is all this stuff, which you get from that. So the degree is 4, the leading coefficient is -2. What you really care about is that it's negative. Then you draw the graph. So even degrees either start high and end high or start low and end low. Because of the negative coefficient, it starts low and ends low. And so you can add in that as x goes to infinity. To the right, you have forever f of x goes to negative infinity. Same thing as you go the other direction, f of x goes to negative infinity. All right, so that takes care of the two examples you gave me. I think it might be good for you to do one either that I make up or that not super difficult. Just have you do one um, on your own here, or if you got other example problems.
Um, so I do have this other type of problem that I also had a question on. Let me pull that up quickly.
Okay.
I was wondering what these two would be. So this is example 2P2. And I'll go back and do some more practice. But what types
So this is going the other direction, and we can certainly do these. Uh, let's yeah, I mean this is sort of awful. But this is your class. You're in the, they want you to be able to do these. I mean, nobody does these by hand ever, but okay, so the first thing is that what you have to remember, or your teacher will tell you, is that the roots come in conjugate pairs. Okay, and it's not just the i's, but we'll get to that. So if it's 5i, that means it's also minus 5i is a root. Okay. The idea is
yeah.
that, like, let's say you're solving x squared equals negative 16, it's plus or minus 4i. These always come in pairs. So why is that important? Well, you want to be able to the goal is to reduce this down to a quadratic because you can solve every quadratic possible. And so if you know one of the roots, well, you know another root, and that'll reduce the order down from an x to the fourth to an x squared. So to do this, you're going to use synthetic division. Minus 3, oops, I want to start with the right coefficient. 1 minus 3, 21 minus 75, and minus 100. And this looks really, really odd, really, really odd at first glance. You're like, why? I've never seen this before. Yeah, it's weird, but you just follow the same procedure. You bring that down, you multiply by 5i. Now you cannot combine these, which is where this gets a little bit
Then
wonky.
you
You
write
get
it,
mine.
yeah, so you write it as -3. I think we did something like this in class for the previous
Yeah,
lesson.
yeah. So now you have to multiply minus 3 plus 5i times 5i. And that's where it gets, again, a little wonky. It's minus 15i plus 25i squared, which becomes minus 25. So the more you can simplify as you go, the better, because you do run out of room here. So this is minus 4 minus 15i. Then when you multiply it by 5i, you get minus 20i minus 75i squared plus 75 becomes minus 20i times 5i becomes 100, or minus 100i squared becomes 100. And you can see now this is where it's like, well, you definitely better do something here to reduce it. Otherwise, you're going to have I terms as your coefficients. These
Yeah.
are actually coefficients of the third degree polynomial, which is really weird. I mean, because if you've never seen that before, you're just like, I could never do this. So this is again where it gets just terrible. One, but then you start seeing some things clean up here. Okay, now I'm back down to just a number. That's 15i. It's minus 4 becomes 20i, which becomes 0. And notice all the coefficients are the same. Or I'm sorry, are real coefficients. So it was an x to the fourth minus 3x cubed plus 20x squared minus 75x minus 100. Then it's now a cubic. Notice, like, I don't rewrite it. I just keep going. I didn't like that. That'll save you some time as well. This is now an x squared minus a 3x minus 4. And so from here, you always try to factor first. Avoid quadratic formula if you can.
Yeah.
Okay. And then you're down to this. Now, this is where it's a little bit Like, well, what do I write? So the roots, you have to be careful between all of this notation. There's zeros, roots, and intercepts. So the roots, intercept zeros are 4, -1, 5i, -5i. These are the zeros, roots, intercepts. These are the intercepts in the complex domain. Uh, roots, zeros. These all mean the same thing. Now, factors, you have to be careful with factors because that's what they want. It's always x minus the root, x minus the root, and so on. That's the, yeah, x minus p, x minus q, and so on. So in your problem here, it's x minus 4, x plus 1, okay, for these, all right? And then it's x minus 5i, x plus 5i. And if you're wondering, well, where do these come from? It's essentially setting x equal to 4, x equal to -1, x equal to 5i, x equal to -5i, and then moving them to the other side of the equation. Or, like we just talked about, you have to subtract the root, but know to account for the sign, the operator. What do you think of all that? Guess you're so excited you don't know what to say.
Yeah, I think I get it. Yeah.
I mean, this is not it. This is very, like, this is a lot of busy work. There's only one thing I think that's busier in this course, and that's um, adding and subtracting rational expressions and solving. So just keep that in mind here. So for P2, again, your teacher doesn't really ever give you like two of the same examples, but they should. For P2, if one of the roots is 3i, -3i, the other one is positive 3i. The other thing is that you should always try factoring out the GCF first. You can see that this has one, 2 x to the 4th plus 4x cubed plus 13x squared plus 36x plus 36. So I would fully expect your teacher to have something like this on a test or quiz so that, it just takes you longer to manipulate the numbers. So I would generally recommend starting with the positive one, 1, 4, 13, 36, and 36. So I'd like you to get involved here, Karthik. I'd like you to um, reduce this, and you should get 0 at the end. So if you don't get 0, you've made a mistake for sure. So give this a try. Let me know if you have any questions about how to do this.
I did not get 0
Okay,
at the end.
maybe I made a mistake here. Let me just double check. Did I divide all these by 2? 1, 4, 13, 36, 36. Okay, so let's take a look here. 1, and then you've got 3i, so it's 4 plus 3i times 3i is 12i minus 9i squared becomes plus 9. And then you add, so you get 12i plus 22 times 3i is 36i. That's good. Minus, sorry, I did this wrong. Get me my order wrong. Okay, it's 36i plus 36i squared becomes minus 36. And then that becomes 36i. And you're right, does not work. 2x to the fourth, 4, 13, 36, 36. 1, 4, 13, 36, 36. Huh. So let me check. I mean, it's possible the instructor didn't come up with the right example here. I'm using, I like going to Wolfram. That's kind of my preferred place to go for stuff like this. All right, let's see. All right, I made a mistake. I mean, what's going on here? So that's 12i. Oh, plus 9. Oh, this should be minus 9. There's the issue. There is the issue. So if I can make a mistake, anyone can. So it's supposed to work. So you're not supposed to be like, wondering. Um, and then this was minus 36 like that. And it's really important that you don't just like make up the last number because you're going to reuse these in the next line. And you can see I've kind of gone back and forth between a plus bi and bi plus a. You might want to be more consistent than me on that. All right, so now from this line, try minus 3i. And again, what you should get is 0 here when you're all done. So give that a try.
Yep, I did. So I got would be yeah 1, 4, 4, 0, and
The
0.
second one, yeah, the second one works out way nicer. It's x squared plus 4x plus 4. So could you now attempt to factor this for us, please?
X. All right, I got x plus 2 and x plus 2.
Yeah, now you might write it like this because it is a
Oh
perfect
yeah,
square
yeah.
trinomial, but big but here, it says in the instructions to write as linear factors. So your instructor wants this. You have to give them what they want.
Oh, so
And then
so it does have to be okay, got it.
yeah, and then you've got x minus 3i, x plus 3i as well. And then don't forget to bring the 2 down. So much to remember. There's just so many places to just, lose credit. All right. Might be good to have you try one on your own. Might, up to you. We can certainly um,
Yeah, I
do
think we should
something
do.
else, but
I think we should do that, and then some more practice with the first type of question as well. There's more
okay.
practice on these two.
Right. Do you want to do more like the first two we did or the second two?
Oh, wait, actually, there actually is one more thing that I'd like to go
Yeah,
over.
of course, of
Um,
course.
so I had to go over these three questions on 4.9, which was on rational root theorem to
Okay,
find a zero.
sounds good.
So I'll just go one by one on those. Then after that, we can do some practice with all three.
So yeah, this is such a problem. So okay. The it's kind of an amazing thing. This whoever came up with this or the why this works, it's pretty amazing. Like um there's this P, there's this Q, and P represents the 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 constant. Q is the coefficient of the leading term. And the possible real zeros come from the ratio of P over Q plus or minus, where P is the factors of P and it's the factors of Q. So you actually have to like figure those out. So for 8, it's 1 and 8, 2 and 4 and 8. For Q, it's just 1. So you take the ratio of these. So it's 1 over 1, 2 over 1, 4 over 1, 8 over 1. So a quiz question is always like to write the possible real zeros. And they would choose one more like number 2, which has some fractions in it and some repetition. But for this one, it's plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. It's each of these numbers over the bottom number. Okay. All right. Now, this is where it gets really bad, hairy, and dicey, my opinion, because they want you as the student to figure out which one of these work. And the answer is like how good of a, you know, how good are you at guessing? Now, if you could graph it, you would know, right? You just know which one it is, and you could try it, but they don't allow you to do that. So you basically have to guess until you figure out which one is correct. So you could potentially, I mean, there's 8 here. You could potentially have to do this 8 times, which is kind of ridiculous, but that is what they have you do. So you try it using synthetic division. Now we don't need to do that. It's just a waste of time. I'm going to tell you the root or a root. But keep in mind in class you'll probably um, have to guess. Now what would you guess? Like what would be your first number you might start with?
Um,
You're taking too long. You just want to pick something like 1, I guess, and just go and see if it works.
God.
Like there is no real way to know if it's a good guess or not.
Okay.
And this is where I think I differ a lot from instructors. They want you to um they want you to guess. they're sort of, and I'm sort of this fundamental, like, no, we would never guess. We would find something that we know works before we would start guessing. So 1 is a factor, and this becomes x squared plus 2x minus 8. Can you factor this for us, please?
Um, that would be x minus 2x plus 4.
So those are, so then you got x plus 4, x minus 2, and then is this x minus 1 or x plus 1?
X minus 1.
X minus 1, there you go. Okay. Now, again, you can get some insight into the way the teacher thinks based on what they write. You can see here at the end, be patient. So teacher's basically saying, like, you're gonna have to do this until you get the right 0. Now there's like one thing you can do. There's one thing you can do, and you'll just have to tell me if you guys cover this in class. Does Cartez or Descartes' rule of signs? That could help you narrow it down to positives or negatives. But
Yeah,
that's
I think we're gonna be going over this lesson on probably Tuesday, so we'll probably know by like around Thursday.
sure. Okay,
Yeah.
good. So this whole like P over Q thing is more applicable for something like this. So give me all the factors of 33 and then all the factors of 3, please.
33 is for 3, there's 3, 6, 9,
No, 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 no.
12.
Factors, not multiples, factors. Numbers that divide evenly into the number.
Uh,
This is not meant to be like crazy difficult. So just keep in mind, you're like maybe we're overcomplicating. Like 1 goes with 33, 1 times 33. That's a factor.
I
And then, like 2 doesn't work, but 3 does, 3 times 11.
think I was thinking it too big, maybe, or I thought
Yeah.
11 would work, but it won't work in 3.
Yeah. So you're essentially finding pairs that multiply together. Um, yeah. See, this is why there's a sort of a smaller thing here. Like students really struggle with bigger numbers. Like your teacher's gonna give you a bigger number than this. She's gonna be like 40 with lots and lots of factors, and then another number with lots and lots of factors. But anyway, so that's your P, that's your Q. Now you take every P over every Q. So 1 over 1, 3 over 1, 11 over 1, 33 over 1. And then you take every P over the other Q, which is going to introduce some fractions. So 1 over 3, 3 over 3, 11 over 3, and 33 over 3. All right, now it's worth reducing here. So you got 1, 3, 11, 33, 1/3, 1, 11 third, 11. Any duplicates you get
Yeah,
rid of.
so
And then you have to remember to put a plus or minus in front. And
got
if
it.
you really want to be that A plus student, you could put them in order if you can. So this is where it's like you would be really frustrated to try these. These are horrible. This is probably what we get on a test. Yeah, yeah, I mean,
All
but
right, so then you would just try one of them and see if it.
yeah, you try until you find one that works. Yeah, it's just kind of like, why? And it doesn't matter. I mean, I'm not the one giving you this, but that's my opinion. Uh,
Go first. Mm.
like I said, in the real world, you would use something like Descartes' rule of signs or something to like point you in the right direction. Um, and there's so many examples of this. Like if you lose something, you don't just search, you know, randomly. You systematic way of doing it. So that's it. I mean, why don't you? Why don't we look at three now? And three we can actually try some because there's not infinitely many. So this one, the only difference about this one is they set it equal to 0. Really not, doesn't really matter. But your P and your Q, you avoid the sign. Like don't worry about the fact that it's -1 or if this was like -5. It's still just whatever the number is because you're grabbing the plus or minus of it. So give me the possible roots here for this one, please.
All right. It would be, see, 1/1, and then 1/5,
Yep. All right.
plus or
So
minus a
now,
bunch.
yes, it's always plus or minus. So here we go. I'd like you to guess, and you have to decide, am I going to try the whole numbers first or the fractions first?
We'll
I
go ahead and
can't
try.
tell you.
We'll go ahead and try one first.
All right, so
So
go ahead and try 1 and -1. And then if that doesn't work, one of them will work. Only 4 possibilities here. I actually think this would be okay to give on a tester because it's not infinitely long. It's just, you know, maybe you guess and save a little time.
yeah, the one works. So I got
5, 5, 6, 6,
the
1.
negative one.
Well,
Once you do the one, then you do the negative.
oh yeah, well, but once you get it down to this, it's now 5x squared plus 6x plus 1. You could factor this.
Uh,
You would I would say it's better to
I
factor. You
think
might
yeah, I think I might have made a multiplication error there because I got -1 for the last part of it.
Well, that wouldn't work, right? Because you're always adding vertically. One does work though. And then this you can factor. So I'd like you to try factoring this, please.
Mhm.
How are you doing on this one?
Uh, I'm just trying to find the what.
Let me grab the answer that way uh, you've got it because I want to do one more example with you. And then it's x minus one. Okay, I'm gonna really quickly show you something else here because I I assume you'll see this in class, but might as well. So here's a new problem for us to look at. Um, they might tell you that one of the roots is 1 minus 2i, which means that the other root is 1 plus 2i. All right, so we're going to put that in the box here and do the synthetic division. You'll want to leave a little more room on these when you're writing out the results. Because it just gets really potentially messy.
Got it.
All right, so this is 1. You multiply, you get 1 minus 2i, which is 1 minus 6i. And this is where you may have to come off to the side somewhere and foil this. It's just not great. 1 minus 2i, 1 minus 6i. Just it's the nature of these things that you just don't get, nice stuff. So you end up getting where you have to then use the fact that I squared is -1. It's really -12 plus the 1 becomes -11 minus 8i, which becomes -2 minus 8i. And ooh, again, you gotta foil here. So although this doesn't look like it's gonna work out. Did I do something wrong? No, I didn't. Okay. Um, oh yeah, I did do something wrong. Whoops. It's -3 minus 2i. Boy, that's bad. That's bad. Um, if you're ever wondering, like, do I do math all weekend long? The answer is no. All right, so this will foil out better. End up being -3 minus 2i plus 6i plus 4i squared. So that's 4i. It's -4, so it's -7 minus 4i, which becomes 2 plus 2 minus 4i. And then you do unfortunately have to factor again. 1 minus 2i times 2 minus 4i, which ends up being, hopefully this works, 2 minus 4i minus 2i. Why isn't this going to work? Yeah.
Wouldn't that be plus 8i squared?
Yeah, but it's supposed to go to 0 here. Did I not write the coefficients right? 1, -4, 9, -10. All right, 1 minus 2i. -3 minus 2i. So I don't know. I'm fumbling around here. It's supposed to give you 0 at the end. I don't see that happening. Anyway, I messed up here. Just put a big red X through all this, but you may get something like that. We'll have to look at it next time. And I do apologize for not getting through this, but you should be well set up for the week. I'm